and tomorrow, we're going to be, the lessons really tie together, 10.5 and 10.6. Okay, 10.5 is perimeters and areas of similar figures. 10.6, we add volumes in there. It's the same idea. Okay, so right now, get the learning goal down, summarize that theorem, and we'll give you guys a couple minutes to work on that, and then we're going to dive in and hopefully give you a lot of time to work on your assignment here. Okay, can I have a volunteer to read the theorem, please? Go ahead, Jody.
If the similarity ratio of two similar figures is A to B, then 1, the ratio of their perimeters is A to B, and 2, the ratio of their areas is A squared to B squared.
Good, so if we have a similarity ratio, so we're going to think of this in a couple different ways. So similarity ratio, if that is, similarity ratio is A to B, then the perimeter ratio is also A to B. So similarity ratio and perimeter ratio are the same thing because you're measuring in linear measurement then, okay, to the first power. Versus an area ratio, if you think in terms of our labels that we use, those are square units, right? You're measuring in 2 dimensions. So area ratio is A squared to B squared. Now, we're not doing volume today, but we will be doing volume. Okay, that's tomorrow. And volume, you're measuring how many? You have 3 different dimensions. So it becomes cubed, A cubed to B cubed. Okay, and that will be the next piece. All right, but for today, we're just going to stick with perimeter and area. And similarity and perimeter, keep in mind, maybe make a note to yourself, they're the same. Okay, so we know how to find the similarity ratio, which gives us the perimeter ratio, and if we square that, we get the area ratio. Okay, that's what that theorem talks about there. Okay, so let's try some of these. This activity says each pair of figures is similar. Find the ratio of their perimeters and the ratio of their areas. Now, I think you have these on the back of your sheet. Yeah. So if you turn that over, you can go ahead and work through these. Go ahead and work with your neighbor. You need the ratio of the perimeters. Okay, and the ratio of the area for each. Let's make sure we've got this correct at the beginning here. So we have 24 is to what? 18. 24 is to 18. And you can double check it. I mean, if you're not sure on the sides, all of the ratios should equal. So 24 to 18, 36 to 27, 32 to 24, they should all reduce to the same thing. And I would definitely reduce them. What do they reduce to? 4/3, okay? 6 goes into both of these. 6 goes into 24, 4 times, and into 18, 3 times. So it reduces to 4/3. So if the similarity and perimeter ratio is 4/3, then the area ratio, we just have to square this. That's 16/9. Okay. How many got it? Okay. Questions on it? Yeah, Gracie?
Would you write it like that, like a fraction, or would you write it with the dot?
I prefer you write it with like a fraction because we're going to eventually use that to find the area. Okay? So it's easier to use in a formula. Good question. So we'll leave it in fraction form. All right, so in this one, perimeter ratio or similarity ratio is? 8 to 5. Do the angles change in similar figures? Tell your neighbor, yes or no? No, angles should be congruent in similar figures. Now, a few of you missed that on your quiz on Friday. Okay, angles do not change. They're the same size in similar figures. Okay, so if this was, in this case, I don't know, 108, I think. I can't remember. But they would be congruent. Okay? So 8 is to 5 as 64 is to 25. We just square them. Okay? They're not proportional, okay, in the sense that they're equal to each other, but they're if we square this, we get that. If we square that, we get that. Yeah?
If you could, would you reduce the area ratio?
Yeah, I would reduce it if you can. Okay. Yeah?
Could you reduce a fraction by using the square root?
No. You mean just make it back 8 to 5?
Yeah, like just bringing fractions in general.
Nope. Okay? How many have this one? Okay, what do we got for perimeter? Tell your neighbor. Okay, 9 to 5. Now let's read them from left to right and top to bottom. So if this one came first, we're going to go 9 to 5. Okay? And then area would be 9 squared over 5 squared, or 81 over 25. Okay. That's what we'd actually want to use. Okay, everyone rate themselves 1 to 5. Okay, let's move on. Let's try this one. This is all for our assignment today. I'm going to go ahead and hand out your assignment so you can reference it while you're looking at this. But go ahead and read those. And I want you to find the similarity, perimeter, and area ratio for each. And kind of list it like this in your notes. So you can just say number 1 off example side or something, and that way you can reference it that way. This is not part of your... This is not on the actual warm-up. This will be off your assignment. Hey, get your attention back up here. So for each pair of similar figures, the area of the smaller figure is given. Find the area of the larger figure. So what we have to use is what we know. We know the similarity ratio. Similarity ratio is 12 to 20. Which reduces to 3 over 5. Good. So we factor out that 4, we get 3/5. Okay, perimeter ratio is also 3 to 5. Area ratio then is, it's 9 to 25. We square this, right? So 3 squared and 5 squared. Okay, what that allows us to do, if we know the area ratio is 9 to 25, 9 over 25, 9 is the smaller, 25 is the bigger, we know that's equal to the area of the smaller over the area of the bigger. Okay, so this is our smaller, this is our bigger. Well, the area of the smaller we know, it's 81. So 9 over 25 equals 81 over X or A or whatever we want to call it. I'm going to leave it as A here. Okay. Any questions on how we set that up? So if we have the area or the similarity ratio, we can find the area ratio and then use that to find the area. So what do we do to solve this? Cross multiply. So 9A equals, it's 25 times 81? What is it? 2025. So what's A? A?
135.
135?
I got 225.
225? That sounds better. 225 square centimeters. Any questions? How do we know that this has to be greater than 81? It's a bigger triangle, right? I mean, start thinking logically. If you get an area that's less than, then you've done something wrong there. You all right? Hey, let's move on to number 2. Tell your neighbor what the similarity ratio is on number 2. Okay, so number 2, it's everyone? 12 to 5. That wasn't everyone, but everyone. Perimeter ratio? 12 to 5. Area ratio? 144 over 25. So just square that. Okay? I want you to set up what proportion you can use to solve this up here now. Do a quick lap if you have any. Okay, how many have an answer? Okay, let's check it out. 144 over 25. Our area ratio is equal to area of big this time over area of small. So in this case, 144 over 25. Area of big we don't know. Area of small is 6. Cross multiply. What's 6 144s? 864 equals 25A. Okay, so 1A, 34.56, perfectly?
Yeah.
Wow, All right. And we'll call that square inch Oz. Okay, we'll kind of cut into that there. Okay. How many got it? Okay, very good. Hey, we have one last problem then. Okay. Let's take a look at it. Number 9 off the example side. Read it. Tell your neighbor what you're going to do, what your plan is, what your plan of attack is there. Okay, what's our plan of attack? What are we going to do? Ben?
You can do 48 over 12 and then square root that in AR ratio.
Okay, so you're here. They give you this, 48 over 12. So we could take the root of it to find the similarity or perimeter ratio, right? We're trying to find the ratio of their perimeters. Yeah?
Riley's not
Riley?
here. Yeah, Riley.
Oh, thank you very much. Okay. Can we simplify 48 twelfths?
Yes.
Yeah, what's it become? 1/4, or 4 over 1 maybe. So taking the root of this is a lot easier now, right? So if we're going this way, we're taking the root. If we're going this way, we're squaring. Okay, so from here to here, the root of 4 is? Root 4 is? Holy cow.
Wouldn't it be root 48?
Oh, we simplified, right?
Oh.
So you said 12 goes into 48 4 times. 12 goes in 12 once. It makes it easier. If you go root 48 divided by root 12, it'll eventually reduce to 2 over 1. So for those of you that kept it like this, 48 over root 12, hopefully you would recognize from here you could simplify. Right? 12 goes into 48 4 times, so it would be root 4 over root 1. Okay. Anyway, the similarity ratio is 2 to 1. All right. Very good. Any questions? All right. That's it. Yeah, Eli.
Why is 1? Why is it 1? Why isn't it root 1?
Why is it what?
Why isn't it root 1?
Because square root of 1 is 1. Okay, your assignment is example side and mixed side all. Oh, yay! Woohoo! I know. Have your attention back up here, please. I had a question on number 3. What's the similarity ratio? Yeah, it's K over 2K, right? First thing you need to do in terms of the similarity ratio, try to reduce it. So what's this reduced to? 1 over 2. The K's cancel. So your similarity ratio is 1 over 2, which means your area ratio is? Good. So if you're calling that similarity, area is 2 over 4. No, it's not 2 over 4. It's 1 over 4. Okay, a squared, right? So 1 over 4. And then you can set that up. Okay? Yes? Yep. So everyone's attention back up here. Number 7, I had a bunch of you ask this question. A gardener uses 30 gallons of water each week on his vegetable garden. So that's covering the area of the garden. So you spray it over the area. The vegetable garden, which is 10 by 12, how much water should he expect to use if he increases to 30 by 36? Well, your similarity ratio is 10 is to 30. So if you think of the garden, you have 10 maybe on a side and 12 here. And it becomes now, thank you. So it becomes now,
Really pretty card.
thank you, 30 is to 36. So 10 is to 30. And 12 is to 36. Those are equal, right? They both reduce to,
3.
how about 1/3?
No, 1/3.
Okay. 1/3, yeah. Oh, well, can I finish this one? Because I'm right in it. So from here we go area ratio. So we square it. So it becomes 1 over 9. And then we get 30 over x. Okay? Whatever. All right. Number 7. 2 circles with an area of 128 pi square centimeters and 18 pi square centimeters. You're trying to find the similarity ratio of each pair of similar figures. Okay, so if your area is 128 pi over 18 pi, reduce it, right? What cancels here? Put your phone away. What cancels? Even if you're playing 2048. Yeah.
Doesn't it reduce to 64?
Yeah, I think. I don't know. I know we can cancel pi's.
Yeah, you can cancel those.
Yeah, the pi's cancel. So we could take a 2 out, so that's 64 over 9. Okay? That good?
8 over 3.
No.
Well, can't go any further than that. Plus, these are both perfect. And we can take, to find the similarity ratio, we got to take the root of it. So this is a squared to b squared. We want to go to a to b. You guys got to tell me when I'm off the screen, man. Otherwise, it's a waste. Seriously. Okay? So this is
8 over 3.
8 over 3. All right. Hey, how many knew I was off the screen? Okay, so what that tells me is if you're not paying attention, I'm not going to go through the questions on it. I'm just going to assume you guys have it. Yeah.
We were only off the screen for like 3 seconds.
Come on. Well, I need it after 1 second
I
then.
didn't realize.
Half a second. Use cat-like speed. Okay?
You got screen. I know. You got screen right there.
All right.
Yeah,
Very good.
Just yell screen.
Yeah, yell screen. Thank